Hi guys, if you find this video helpful, please like, subscribe and press the bell icon for notifications. So today in complex numbers, we will be learning about the modulus of complex numbers. So modulus, absolute value or magnitude, all are the same thing, and it is denoted by mode of z and is always positive. Now to find the value of modulus of complex number, let's take any complex number z is equals to a plus bi and graph it on the complex plane of real and imaginary axes by moving a unit to the right and b unit up, and then join that point of coordinates a b to the origin to get complex number z is equals to a plus bi, and the length of this line segment is mode of z. Length cannot be negative, so therefore its absolute value z. Now in triangle PAO with sides mode of z, b and a, modulus of z square is equals to a square plus b square by Pythagorean theorem, and from here we will get the value of modulus of complex number, that is root of a square plus b square. Now if z is equals to a, that is pure real number, so a is pure real here, then z can be written as a plus 0i and its modulus will be root of a square plus 0 square, that is root of a square or mode of a. So we can say that mode of z is equals to root of a square or modulus of a when a is a pure real number or z is pure real number. Now if z is equals to bi, that is pure imaginary number, so bi is pure imaginary here, then z can be written as 0 plus bi, then its modulus will be root of 0 square plus b square, that is root of b square or mode of b. So we can say that modulus of z is equals to root of b square is equals to mode of b when z is pure imaginary number. Now let's take an example where z is equals to 2 plus 3i, then its modulus will be root of a square plus b square, where a is 2 here and b is 3, so we will get root of 4 plus 9, that is root of 13. Now let z is equals to a plus bi be any complex number, then its conjugate will be a minus bi. So now just take the modulus for z and conjugate of z, then we will get root of a square plus b square, and for conjugate we will get root of a square plus minus b square, which will give us root of a square plus b square, which is equal to mode of z. So we can say that mode of conjugate of z is equals to mode of z. Now if z be any complex number a plus bi, then negative of z will be minus a plus minus bi. Now take their modulus, then we will get root of a square plus b square, and for minus z we will get root of minus a square plus minus b square, which will be root of a square plus b square, and again it is equals to mode of z. So we can say that mode of minus z is equals to mode of z. Now let z is equals to a plus bi be any complex number, then its conjugate will be a minus bi, and then z times its conjugate will be a plus bi times a minus bi, which will give us a square minus bi square, because it's in the form of a plus b times a minus b, which is a square minus b square. So now we just need to substitute the value for I square, that is minus 1. So we will get a square plus b square. Therefore, z times its conjugate is equals to a square plus b square, or z times its conjugate is equals to mod of z square, because we know from the modulus formula that mod of z square is equals to a square plus b square. Similarly, we can prove that modulus of z1 times z2 is equals to modulus of z1 times modulus of z2, and modulus of z1 divided by z2 is equals to modulus of z1 divided by modulus of z2. So modulus, absolute value or magnitude, all are the same thing, and the modulus is denoted by mod of z, and if z is equals to a plus bi be any complex number, then its modulus will be root of a square plus b square by Pythagorean theorem. We also proved that mod of z is equals to mod of a if z is pure real number. Similarly, the mod of z is equals to mod of b if z is pure imaginary number. Then mod of z is equals to mod of its conjugate. Then mod of z is equals to mod of negative z. Z times its conjugate is equals to mod of z square, and mod of z1, z2 is equals to mod of z1 times mod of z2. Similarly, mod of z1 over z2 is equals to mod of z1 over mod of z2. Our next topic will be properties of conjugate. Thanks for watching.